Hi folks, in this video we will talk about the solution of this Codeforces round which is currently ongoing. Hopefully I will be able to complete this video and upload it and everything before the contest ends. Yeah, so this would be an experimental video. If people found it useful, then I will consider making these videos more of fun. Yeah, so let's get started. And I will attach the contest link in the description. So if anyone wants to spend more time reading the problem statement or stuff like that, then they can do that, because obviously I already solved it. So yeah, I won't need to spend much time looking at the statement itself. Okay, so this is the first problem. Basically, this problem is asking us, they have given us the sum of these characters after characters are converted to these numbers, and we have to find the lexicographically smallest substring. Yeah, so this is a very simple problem which is expected because it is the first problem of a div 3 round. So what we can do is that we can just simply run three loops and just iterate for all possibilities. Whenever you found it can find a sum, then we just assign this string as this answer and we return it. Yeah, that's it basically. And your time complexity would be fine because 100 multiplied by 26 cube. Let's go to the second problem. Okay, make equal. So the thing is that like we have n containers. Every container has some water in it, and eventually we want to make amount of water in all containers equal, and we are given that sum of total water is divisible by this, so it is possible to do that without going into floating points. So the first step would be we can find the average, which would be sum of all water divided by n, so that we know what is the expected number of uh, water in each container after all the operations are done. Okay, so let's see what operation we can do. All right, so we can basically move anything from lower index to higher index. That means we can't move anything from higher to lower. All right, so basically the flow of water can happen in only one direction. So let's see here, if at any point, let's say these are our containers and we are here, let's say average is x and these are 5 containers. If water in these is more than 5x, then it means we are failed. Why? Because the water can never go down, and it can always travel in this direction. So if it is more than 5x, then we know for sure that we can never make these containers water equal. So yeah, we just start from the back and then we check this condition. So let's say if this is 7, then we compare the water with 7x, 8x, 9x. Yeah, so we just start from the back and iterate in this direction and check for this condition, whether the sum of water in those cells is less than equal to the final water required, because water can always go from in this direction, but it can never go in the previous direction. Okay, yeah, that is done, and we're just iterating one, so yeah, that would be fine. Let's move to the problem 3, make equal again. So one main thing to notice is that we can do this operation at max once, and it wants us to make all the elements of the array equal. So let's see here. Let's say we have this array. In the end, first look at this case. Let's say first element is x and second is y. then we are making a claim. It is always better to make all the elements equal to x or equal to y, because if we are making them equal to some other element z, then that would mean we will have to take the whole array, as we can only do that operation only once. So we will have to take the whole array, which is the worst case scenario. So obviously we will either have to make all the elements equal to x or all the elements equal to y. So one option would be, let's say all these elements are x x x x and these are y y y y. So one option would be we take this subarray and make all of them equal to x, and the second option would be we make this subarray and make all of them equal to y. So these are the two possibilities. We will take the best, basically, like when we have to take lesser number of elements. Third scenario which is possible is that when x is equals to y, in that special scenario we can just take this subarray and we will be done. That's it for the problem C. Let's move to the next problem. Problem D. Okay, yeah. So for this problem, first look at a relatively simpler problem. Let's say we just had one condition and they're asking us, okay, find all the pairs when ai plus aj is divisible by x. What would we do in that scenario? Oh, okay. Just to reiterate again, we are ignoring this condition and we are just trying to find the total number of pairs when ai plus aj is divisible by x. Okay, so let's say we are keeping a map and we are storing ai modulo x. So we have this array, we start iterating from this end, and we are storing, we are using map to keep account of this. Okay, so let's say we are at the jth index and current mode is this aj mode x. So we know mode, right? And when sum of two numbers are divisible by something, then we know their mode would be 0. So from this equation, if we know mode of aj, we can find the mode, like what is the required mode of other part of this pair. So let's say we'll put ai plus mode here and mode x. So we have this equation. So like from here, we can simply find out the required mode for the AI, right? And those things we are storing in our map already. So we can get the count directly from here. After that, we increment the count for the current element also. So in this way, like if we are to just find when ai plus is divisible by x, we could find that simply. Okay, now we have two conditions. Fine, like, so what? I mean, that doesn't say anything. Like, so basically, instead of just storing one value, I will store two value in this map. This would become a pair. I will also basically, instead of just storing this, my map will store a pair, which would be first value would be mode of x and the second value would be mode of y. So in the similar way, how we found what is the required mode of AI, we can find the same thing with respect to modulo y also, and then we can search those pair in our map and add the count to the answer. Yeah, By the way, like I will also attach the links to my code for any of the problem. Like if you want to see like how to implement them, then you can reference my code. Okay, let's move to problem E. All right, so we have this bunch of operation and yeah, in the end we have to tell who will win with optimal play. Okay, so few things we have to sort of notice from the statement is yeah, like the general idea in these type of problems, right? We always should try to see what is actually happening in every operation. So there are two operations. Anna is doing something, and then Sasha is doing something. Okay, so basically, when Anna is doing an operation, so like she is reversing it, and the zeros get removed. So basically, we can see that whatever was the number of zeros in the end of that number, those are getting removed. So let's say in a way, total number of digits we had is getting reduced by the ANR operation. And similarly, by the Shasha's operation, we are combining two numbers. So in a way, you can see that the choices for Anna are getting less and less because in the end, so like Shasha wants that the number should be as big as possible, and the Anna wants uh, sort of opposite of that, which would mean like number should be as less as possible. So like 10 to the power m means m plus one digit in the number. So if we can get m plus one digit, then Shasha would be happy. So like she would always try to like keep the count of digits high and high. All right. So let's see. Let's try to consider yourself in both of the places. If you are Anna, you would always try to choose a number which would make it like which would make number of digits as less as possible. So you will choose a number which have most number of zeros in that. If you are Shasha, you will try to like reduce that opportunities. If there is a number, let's say for example, if we had 20, 30, 400, and now Shasha's chance is there. So what Shasha can do is she can 400 plus 30. So like whenever Shasha is doing her operation, whatever the first number is, for that number now Anna can't choose that number. So basically after the Shasha's operation, Anna can't reduce this to zero. So whenever Sasha gets a choice, she will put this highest number. By highest meaning the number having the most zeros in the beginning and any number in the end. The number in the end doesn't really matter because I mean just this number is changing. For this number there was already 1 0 in the end, and after this like still there is 1 0 in the end. Cool. So now we understand like what is the effect of both of those operations. So and yeah, and one more thing is let's say we have 1580 and Anna chooses it once, it becomes 851. So like from Anna's perspective, there is no value in choosing this number again because after once it will never have zeros. So yeah, Anna can't choose this number again and like reduce the count. So basically these count, right? This count, like this number will always add 3 to the total sum. So what we can do is we can calculate total number of these digits, which we know for sure will be there. So let's say if the number is 1000500, then we know these two zeros can be reduced, but the remaining four zeros, yeah, the remaining four digits will be there for sure. So first simple thing is we can count number of all these digits If that itself is already greater than equal to m plus 1, then we know for sure like Shasha is going to win, because no matter what happens, this is the least number of digits that will be present in the final answer. Okay, after that we have a bunch of numbers, right? So it's as simple. Whenever Anna gets a choice, she will choose the number with the highest number of zeros. Whenever Shasha gets a choice, always she will also choose that number and combine that number with something else so that Anna can't choose that number. So what we can do is we can store the trailing zeros for all the elements, and then we can sort them. So the highest will be taken by Anna, second will be taken by Sasha, which means like those zeros are not getting reduced from the total answer. So yeah, we can just keep assigning alternate to Anna and Sasha. Sasha's digits are actually getting added to the final answer. So after doing that, if the total number of digits present is greater than m plus 1, then again Sasha wins, otherwise Anna wins. Cool. Yeah, we are just sorting, so it will be like Anna Flogan. And yeah, so one more quick thing about that, you don't actually need to sort also, because the maximum number of zeros in the end will be 10 at max, right? Because the number is at max 10 to the power 9. So maximum number of zeros can at max be 9. So you can just do a like frequency count basically. Yeah, you can call it like Redix sort basically. Like you don't actually need to apply and log in. So yeah, this would be like linear final solution. Okay, let's go to the problem F. Yeah, G was the most sort of interesting problem, which is kind of like expected because yeah. But yeah, let's talk about F. So basically, like we are given k orderings, and in so the first number kind of becomes like not useful because that is equal to the user which is posting it. But yeah, after that, every number is sort of useful. All right, let's see how we can solve this. Okay, what I'm doing is that I am basically keeping this position, which will have our sort of a position of all the uh, elements from 1 to n, all the users basically. And basically, it doesn't matter what it contains, but you can probably store like some sort of numbers in this. But the point is that if let's say x have 7 and y have 12, that would mean that we think x comes first in the actual order and y comes later. Okay, so let's do this. So we have k orderings, right? From here to here, 1 to k. So if we look at first ordering, then okay, first number is not useful. But after that, whatever number is there, let's say we have 4, 7, 3, 2, 1, 5. That's a total number of users was 7. So just from the first only, right? Just from this one screenshot, we know the relative ordering of all of these numbers already. Only one number we don't know, because that is like 6, and so 6 is coming in the beginning because 6 is the one who is posting it. So what we can do is, let's say if I tell you, okay, I want to assign 1 to the 4. Uh, let's say we have this 1 2 3 4 5 6 7. If I say I want to assign 1 here and 2 here, 3 here, 4 here, 5 here, and then 6 here. Okay, these are the number I've already assigned. Then whenever now next we need to do comparison between any of these numbers for which we already filled the value, we can already compare between them. So in like any of the next k orderings, if first we have a 5, then we have a 4, we can just tell, oh, it's not possible because 5 have 6 and 4 have 1. So like 5 should always come after 4. Cool. So for n minus 1 number comparison, we already know sort of the condition. All right. Now first list is done. Only thing is that for 6 we don't know. But in the next list, right? In some next list, 6 will come in middle. Okay. In some next list, let's say here it will be X and 6 will come here. Then so in all the lists, right? Whatever numbers are present here, we will just keep iterating the list from here to here, and we will just keep comparing. If at any point the current list doesn't satisfy our ordering, then we say this is not possible, man, and we just exit from the test case. Okay, but we come to 6. Okay, now we don't know, but the thing is that there would be something behind 6, and so let's say 3, or if the 6 is the second number, then let's say 7. Basically something would be here, right, adjacent to 6. If there is anything else adjacent, then with respect to that we can assign 6 a number. So yeah, one problem can be, okay, I mean, we assign consecutive number, but what do we do? So let's say 6 came after 1. 6 came after 1. Here was 1, and then we have 6. So what we can do is, we see the value of 1, which is 5. So we can say, oh, okay, we will assign 6 to the 6. Cool. Now we have a full ordering for all the elements. Yeah, so one more problem can be there. Okay, we now got the full ordering, but still, like, in some scenarios there can be like a discrepancy, like it is here, right? 5 and 6 both have 6 6. So we just keep iterating. At any point, if 5 and 6 comes consecutively, then we can fix the order. For fixing the order, like, I mean, there can be many possibilities, but like what felt like the most simple implementation to me was, I just assigned, okay, if we have 5 first and then 6, then at that point I just change this to 5.5 and this to 6.5. That's what I did. But yeah, you can do a number of things for doing this. But yeah, so at any point, if that happens, we assign this, and now we are full ordering. So the point is that we don't need to search for any of these things. Whenever we are comparing two consecutive values, and if we see one of the values is not assigned, we assign that value based on the previous value. And whenever while comparing we see, okay, both of these have same numbers, then we can just do these kind of things to finally decide the order. If at any point of comparison the ordering is against like what we know till now, then we say, okay, boss, this is not possible. Cool. Yeah, okay, so let's go to the final problem. All right. Yeah, so this is an interesting problem, and if you didn't try it, I would strongly recommend you to try it. And then, yeah, this was a very fascinating problem. And the solution, like, at least what I did was like very different from, like, I mean, what you can get the feel from it. Yeah. So, first of all, like, one thing you can notice is that, so there are like, you can combine this one with this. So, if one portion is out, then the other portion should be s- sort of shallow, so they can combine with one another. So what I'm going to do is I'm going to assign all of these a um, sort of a binary symbols. Let's say, okay, so focus clearly. Like, if I have this, then for the left hand, if it is outside, I give it 0, and if it is inside, I give it 1. For the right side, if it is outside, if it is inside, I give it 0, and if it is outside, I give it 1. uh, to notice, I am assigning opposite parity. Like, on the left side, inside is 1, on the right side, that is 0. It would become clear why I'm doing that. So if we have this, if we have this box, I will assign this 1 and 0. So the reason behind giving opposite parity was so that if I can just check whether we can say if these two numbers are same, then they will connect, because 0 will connect with, so this outside one will connect with the inside one. That's why I gave the opposite parity in the beginning. So yeah, by doing this, we can convert all of the symbols which we have here to like two digit two digit bit string, right? So after this conversion, we have 0 1 1 0 0 0 1 0 count of all these substrings. These are the four things which we are given. So the problem now becomes, we have to find number of binary strings where the where we know the count of all the four type of like binary substring of size 2. Obviously, like, these are the only four scenario possible, right, for substring of size 2. Okay, yeah, things would take a I think this problem would have like many more solutions, and but yeah, this solution was like super interesting to me, and like uh, felt very simple. But yeah, it may not be the case for you, but I think this is very interesting to learn and like sort of useful to solve like more similar problems. Okay, so now I'm going completely different. So I'll make a finite state machine kind of thing, or just a like flow of states. Okay, so let's say this is 0, this is 1, and if we move a operation 0, we come here. If we do a operation 1, we come here. If we do a operation 1, we come here. If we do operation 0, we come here. So like the state indicates, so this name of the state, this indicates what was the last digit in the binary string. All right, and the fascinating part is, if we can reach this state, the problem is done. So like, to solve the problem completely, we will need to consider two cases. First, the string start with 0, which means initially we are here, or initially we are here. Okay, let's solve one case. The other will be solved exactly the same way. If we are here, then just by the state diagram, right, we can see like some condition already. If the number of states, if the number of transition of 0 to 1 and 1 to 0, if the difference between them is more than 1, then we know the answer would be 0, right? Because we will be stuck here, and if it's more than 1, then we can never make those transitions. And the second thing is that, okay, let's say that in our state diagram we are never able to reach this state, then 1 1 can't be achieved. Similarly, if we can't reach this state, then the 0 0 transition can't be achieved. All right, like how do we actually find this? Okay, let's say we are starting from 0. Okay, and we know transition, we have 4 transition to 0 to 1, 0 1 4 transition, and 1 to 0 is equal to 5. Okay, they can't be 5 if you can't sum 0. Let's say they are 3. Hmm. All right, that means if we are starting from 0, we will end here. We start from 0, 4 times we are going here, so go back, go back, go back. So in the end we will be here. All right, so if I ask you, you have to, let's say 0 0 strings were 10. So 0 0 can only be done when we are at this straight, right? And we want to calculate how many times we are at this state. Once in the beginning, and then we are coming back here 3 more times. So we are at this state 4 times, and we have this 0 0 as 10. So we just need to divide those 10 occurrences across this 4 state, because I mean, for example, one case can be we do all the 0 0 transition in the beginning only, or we do some in the beginning, then in some after we come here like for the first time. So for this scenario, what the answer would be, it would be like the standard case of we have k objects and we need to divide it into n objects, or divide into k partition. So basically it would be, if this is 10 and we are coming here 4 times, then it would be uh, 10 plus 4 minus 1, 4 minus 1 combination. This is a standard thing, like n plus k minus 1, k minus 1. Oh, oh, this can be like deduced also if we assume 10 states like this in, and then we are trying to split them in 4 parts. So like fourth would come in the end, and then we have 13 here, and we are trying to do 13c3. All right, so we will do the same here, this side. How many times we are coming at state 1, and then how many times we want to do 1 1. And yeah, that is the answer. If this is not clear to you, I would like strongly recommend you to like try doing this on pen and paper. Yeah, and like I strongly did recommend like actually trying to solve this and understand this, because yeah, this problem had like a lot of things to teach in my opinion. Okay, yeah, contest is also finished. Let me try to upload and post this video. But yeah, if you found this useful, like the video and comment. That encourages me to like make more such videos. Yeah, and cool. I guess bye bye.